Hello friends, let us see some basics related to concept of inheritance in Python. Inheritance is the capability of one class to derive or inherit the properties from another class. So this is basic definition as far as inheritance is considered. It is a powerful feature in object-oriented programming. It refers to defining a new class with little or no modifications to an existing class. The new class is called derived class, or it is alternatively referred as a child class derived from the parent class. And the one from which it inherits is called the base class or parent class. So in general, the syntax is just as there will be a base class and then body of that base class, and from that there will be derived class and then body of the derived class. So it represents the real world relationship as far as parent and child kind of terminology is considered. It provides reusability of the code. We don't have to write the same code again and again. Also, it allows us to add more features to a class without modifying it. It is transitive in nature, which means that class B inherits from another class A, then all the subclasses of B would automatically inherit from class A. So this is something which is very useful feature. As far as object-oriented programming is considered, this inheritance is one of the most important aspect and kind of a facility provided. In inheritance, child class acquires all the data members, properties and functions from the parent class. Also, a child class can provide its specific implementation to the methods of the parent class. So these are certain features with which we can proceed. Inheritance makes objects or classes special, derive new classes from existing ones, extend the definition of existing classes, override method definitions of existing classes. Inheritance is going to create objects of different classes in the same program, allow objects to communicate with each other, and create more complex objects by combining simpler ones. So there are different categories, or we can call it as say types of inheritance. In Python, based upon the number of child and parent classes involved, there are fundamentally 5 types in general. So that is single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. So first of all, we can have a simple, say, relationship as a real-time example where there may be a car, and from that again there are categories. So like there is maybe a van or sports car or some convertible kind of a car, or say for example your animal. Then from that there are again categories like reptiles, mammals, fish. Then under mammals category there may be dog, cat, human, and so on. So like this, this is a categorization or real-time model of inheritance. The features and properties are inherited. Using inheritance to create new classes, an element of OOP that allows a new class to be based on an existing one, where the new automatically gets or inherits all of the methods and attributes of the existing class. The children classes get all the capabilities and properties, that is attributes, and the parent class has whichever the parent class is having, and the children classes are also called derived classes. Now we can go for some sort of examples. To create specialization of existing classes or objects by adding new attributes and methods, often called subtyping when applied to the classes. In specialization, the new class or object has data or behavior aspects that are not part of the inherited class. Overriding, as far as considered, overriding of there may be operator or different meanings, then addition of 2 numbers and concatenation of 2 strings, like that. The same method does different, so the name is kept the same. Alternatively, the behavior of the particular one, that is to redefine how inherited method of a base class works in derived class. Two choices when overriding: completely new functionality versus overridden method, and incorporate functionality of overridden method or add more. So these are the two possibilities. Then second feature associated with inheritance is polymorphism. Polymorphism is an aspect of object-oriented programming that allows you to send same message to objects of different classes related by inheritance and achieve different but appropriate results for each object. We will go for examples of each one of this concept. Then with multiple objects, we can have multiple objects in a program, like communication between objects. One object sends another message when it invokes a method of the other. Like that, we can exchange parameters and values as well. Now, as far as types, as I mentioned, there is a single inheritance, multi-level inheritance, hybrid inheritance, multiple inheritance, and hierarchical inheritance. So, in case of single inheritance, a single Python inheritance is when single class inherits from class. Python multiple inheritance, that is multiple Python inheritance, are when multiple Python classes inherit from a class. Multi-level inheritance in Python, when one class inherits from another, which in turn inherits from another. So it is multi-level kind of a Python inheritance. And hierarchical, as far as considered, when more than one class inherits from a class, it is hierarchical Python inheritance. And hybrid inheritance, as far as considered, then hybrid Python inheritance is a combination of any two kinds of inheritances. So this is just briefing about the types. So here there is a single inheritance. You can see in the figure, that is A to B. This is from base class, one derived class. In case of multiple inheritance, from C class is derived from A as well as B. That means there are some features from here as well as from B class. As far as multi-level is considered, then base class, say for example A, then from that B is inherited, from B C is inherited. So this is base class, intermediate class, and derived class. So like that it may go on. So these are the three, like this is single, this is multiple. So that C class is going to inherit something from A as well as from B. Like here we can just correlate, like this is father and mother, and this child is going to inherit properties from both of them. And here it is only say from derived class to base class to derived class. And here this is say generation wise. So this is a grandfather, father and child. Some properties, some features, some parameters, the way we define in concept of inheritance, same manner in the real world, this kind of inheritance may be observed. Then this is a simple example. So there is one more thing, that is a super function can be used. It is a handy one. It allows us to call a method from the parent class. So like this, say for example, here is a class vehicle. We have defined one start self and one message as a starting engine, and then stop, then stopping engine. And now we have a class two-wheeler which has been inherited from vehicle class, and now we have written say and super.start. So here we have called, and then say for example one message, and then super.stop. So say for example Pulsar is equal to two-wheeler. So here we have instantiated, and then when we say that Pulsar.say, so at that time once it will like print the first one and then second one. As far as subclasses, we will see the examples at actual programs. I will show you the execution. This is just the first part. Subclass may change the functionality of a Python method in superclass. So it does so by redefining it. Like this is nothing but overriding. See here in class A, say hi. This is so print I am in A. And now again in class B, I am saying same method, say hi, but the message is I am in B. So when we are going to create this object from derived class, and when we invoke, then automatically this particular message will appear. So this is basically the concept as far as inheritance is considered. So some theoretical part we have discussed, And now in coming session, we will go for the programming.